Chapters 17 and 18 talk about probability. And the first way that we like to think about that is by thinking of the word chance. So chapter 17 is thinking about chance. Let's motivate this with some examples. What is the chance of getting killed by lightning? How could we come up with a number for this? Well, we know the U.S. population, roughly, is about 300 million, and we have an average of 80 people per year killed by lightning. So what are the chances of being killed by lightning? Well, we could take 80 divided by 300 million. That would be the proportion of the population that get killed by lightning. And if you punch that in your calculator, you get 2.67 times 10 to the negative 7th. So that's scientific notation. And that means you move the decimal over 7 places to the left. So that's going to give us 6 zeros and our 267. So the probability of getting killed by lightning is teeny, 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 tiny. Even if we change that to a percent and move that decimal over 2 places to the right, we would have 1, 2, 3, 4, 5, 6, 4 zeros. That part of a percent. All right, so what if we asked what are the chances a randomly selected undergraduate student at the Columbia campus of the University of South Carolina is in the College of Arts and Sciences? Let's take a look at our enrollment. Visiting the link that is in your lecture notes, we come to this page. And there is undergraduate enrollment information at the top and graduate at the bottom. So we're going to look at undergraduates, and we want to know the probability a randomly selected undergraduate is in the College of Arts and Sciences. Well, we see that the total number that are in the College of Arts and Sciences, the College of Arts and Sciences is this third category, the third college down on the list. There's full-time, part-time, and the total number is 8,014. And then the total number of students enrolled as undergraduates at the Columbia campus, University of South Carolina, is 24,180. At least this is the most recent data that we have available as of this recording. This is the fall of 2014, but the website only has through fall of 2013 updated on it. So we'll use those numbers. So if we want to compute the probability, we can play the same game that we played before. 8,014 students in the College of Arts and Sciences divided by 24,180 total undergraduate students. And that comes out to be 0.33. So roughly 33% of the students, undergraduate students at the Columbia campus, are in the College of Arts and Sciences. Now, thinking about probability. So we usually think about chances in terms of percents. That's just the way that we talk in layman's terms, usually when we're having conversation amongst our friends. Probability actually goes between 0 and 1. It's a proportion or a fraction that goes between 0 and 1. And we have a formal definition of probability. So let's think about probability. First, a question. Is the outcome of the coin toss before a football game known ahead of time? Do we know if it's going to land on heads or tails? No, of course not. This is not known ahead of time. So why then, if it's not known whether it's going to turn out to be heads or tails, it's random, we have no idea which way it's going to turn out, why is it okay to use the coin toss to decide who gets the ball first? Well, we know that in the long run, 50% of the coin tosses are going to be a heads and 50 are going to be a tails. So in the long run, it's fair. So we know in the long run, there'll be 50% heads and 50% tails. So in the long run, we would get the ball half the time. which is fair. So this is how we're going to think about probability. This is exactly the idea of probability. That coin flip is unknown, it's a random outcome in the short term, but in the long term, it's got a regular and predictable pattern. So the idea behind probability is that chance behavior is unpredictable in the short run, but has a regular and predictable pattern in the long run. So now our formal definitions. Random is when individual outcomes are uncertain, but there is a regular distribution of outcomes in a larger number of repetitions. So that's a random outcome. Once you discover what that regular pattern is in the large number of repetitions, and you put a number on an outcome to describe how often it occurs in that pattern, that's the probability. The probability is a number between 0 and 1 that describes the proportion of times the outcome would occur in a very large series of repetitions. We want to accentuate that random in statistics does not mean haphazard. In statistics, random describes a kind of order that emerges only when we can observe it in the long run. Probability describes the long-term regularity of events. A probability of 0 means the outcome is never going to happen. A probability of 1, our highest probability, is that the outcome happens on every repetition. A probability of a half is that the outcome happens half the time in a very long series of trials. Accordingly, a probability of a quarter means the outcome would happen a quarter of the time in a very long series of trials. Now this is on the probability scale, so a 0 probability would be a 0% chance of occurrence. A probability of 1 would be 100% chance of occurrence, and a probability of a half would be a 50% chance of occurrence. So how do we figure out the probability of something happening? We're going to introduce 3 ways in this course. 2 of them are based on scientific foundation, and the third one is not. The first one is empirical or experimental. If we repeat an experiment many times and calculate the proportion of time each outcome occurs, that's an empirical probability. So let's say that we roll a die 10,000 times to see the proportion of ones, then we would have gotten that estimate of the probability as an empirical probability. A theoretical probability is if we make some assumptions based on a set of theories to calculate the probability. So if we say, okay, this coin is weighted equally on the head side and the tail side, so if we flip it, it should have a 50-50 chance of being on heads or tails, then we've arrived at our probability through a theoretical framework. A personal probability is our own personal judgment, but not necessarily based on a set of theories or previous observations. Personal probabilities are not limited to repeatable settings. They're useful because we base decisions on them. This is simply expressing individual opinion. It can't be said to be right or wrong. So personal probabilities are those ideas you have in your head that make you make decisions every day. Thinking about whether the guy you like is going to be at a certain gathering versus another one, you might hedge your bets on which one to go to. This is a personal probability. In sports, we use personal probabilities all the time when we think about the chances our team is going to win. So personal probabilities are those that we use every day, but they're not necessarily based on science. We can think about probability as the number of ways an outcome can happen divided by the total number of possible outcomes. So in a formula, it looks like this. The probability of an outcome is the number of ways for the outcome to occur divided by the total number of outcomes. If we use this formula to estimate the probability of rolling a 2 on a fair 6-sided die, then the probability of a 2 would equal the number of ways a 2 can happen. How many sides on a die have a 2 on them? Just 1. Divided by the number of total possibilities. How many numbers are on all the sides of the die? 6. So the probability of rolling a 2 is 1 out of 6. Now we're going to use this formula to compute the probability of rolling an even number on a fair 6-sided die. So the probability of an even number, remember, is the number of ways it can happen divided by total number of outcomes. So how many sides of a die are even? We've got the number 2, the number 4, and the number 6. So 3 sides of the die are an even number, and how many total number of sides are there? 6. And 3 out of 6 is another way of saying a half. So the probability of rolling an even number on a fair 6-sided die is a half.